Okay, I want to continue on with joints. Let me get a share screen going. So we did the hinge joint. We made the swinging door and the chain. I want to look now at the spring joint, and the spring joint, as the name suggests, acts like a spring that is connecting the anchor point to the connected object. So here's a very simple example of a spring joint. I've got a ball. I have this little cube up here in the top. Get it in shading. So I have this little cube, and I have the sphere, and the sphere has a spring joint, which I didn't connect it to the cube. I left it free, which means it's connected to the world. We have similar features with the spring joint. There's the little orange dot gizmo. They're very hard to see unless you put it in wireframe mode. But there's the little dot right there. And this is the anchor that this is going to move to, the point from which the spring is calculated. So we have the connected, the object to which it's attached, the anchor, the point relative to the object. This is the dot. We have min and max distance. These are the anchor points that kind of define the range on which the spring is active. And it's when it's outside this range. Between min and max, there's no spring force. So for this little case right here, I have a min and max of 0 to 0.5. So when it's close to its anchor, between 0 and 0.5, the spring doesn't act. It's only when it's outside the range, greater than 0.5 away, that the spring comes into play. So let's see it work here. It basically bounces like a spring. There's nothing to it. Now, it of course, a spring has a strength, and any spring needs some damping, otherwise it will oscillate forever. And so we specify a spring strength and a damping, and of course the usual brake force and torque that it breaks. Now I want to switch gears here now and look at an application of the spring joint, which is to give us the ability to drag objects around in the world. And let me change scenes here. So here I have a world with a whole bunch of stuff, including that spring that I just played with there. There's the spring. Here's our hinge joint. And over here I've got our fixed joint and some other weird stuff bouncing around. And what I want to be able to do is point to something, left click it, and pick it up and drag it across the world. That's what I want to be able to do. And I can grab these different pieces and move them around the world. And this is done with a spring joint. So of course it's done with a program. So in drag rigid body simple, I have various exposed variables. These show in the inspector. I have the spring strength, the damper, two drags, drag and angular drag, and a distance. And I have private variables. These are global in the script, but they don't show in the inspector. A private spring joint. And in the update function, the one that occurs every cycle, I have various reasons where I would quit this. well, first of all, I need to find a camera. I'll show you that in a minute. If I have not pressed a mouse button, I bail. If I have not hit an object with a ray cast, we'll talk about how those work later, I quit. If the thing that I've hit is not a rigid body, or it's a rigid body that is kinetic, I quit. So these are all the bailouts in the update function. Any of these things happen, I quit. Now, if none of those things result in this quitting, I then test to see if I have a spring joint. Now, this only makes a spring joint if it doesn't have one. Once it's made it, it keeps it around. And so this only has to happen once. And here I'm going to create a game object, a new game object called rigid body dragger. I'm going to add to that object a rigid body component, and I'm going to add to that object a spring joint. So game object GO is getting a rigid body and the spring component, and I'm setting that body, the rigid body, is kinematic to be true. So this is going to be a rigid body that we're controlling by script. This only happens the first time I use this. Once it's done, this object is made and it's there and it persists. I can show you that here. If you watch down in here, when I play this and I grab one of the objects, you see the rigid body dragger is created here. It's a rigid body, it has a spring joint. At this point, because I've let go of it, it's no longer connected to anything. So if I have a spring joint, I set its position to be the hit point, the thing that I hit with my ray cast. This is the hit, the thing that I hit. And I set its position to that hit point. I set its anchor to 0, so it's going to, the spring is going to be attached to the hit point, well, to the vector 0. I assign spring and damper and distance, and most importantly, I set connected body to the hit rigid body. So this thing that I've hit is now the connected body. Now it's all set up. Then I start the drag object coroutine. We'll talk a lot more about coroutines in a bit, but they're special kind of functions that have a type I enumerator. It has this argument hit distance, which was hit distance. It is the distance to the hit object. This is one of the features of a ray cast, is that the hit that it returns has a function distance that tells us how far away it is. So before I start moving the thing around, I want to catch copies of its drag. That's because I'm going to set the drag, and I want to be able to restore the drag. So old drag and old angular drag are just the spring joint connected bodies drag and the spring joint connected bodies angular drag. So I'm just catching them because I want to set them back when I'm done with this. Some object that we're moving might have specially defined drags that we don't want to destroy when we move it. But then I set its connected bodies drag to the drag and angular drag that are defined up here in our properties. And again, here I'm finding the camera. The find camera is just a very simple thing. If the component, if the object I'm on has a camera, if get component camera, I return that camera. Otherwise, I find the main camera in the scene. A main camera is one that is tagged as main camera. So this first person camera is tagged to be main camera. And so it'll find that automatically. So, so in this drag object routine, while the mouse button is pressed, I'm going to continue to cast this ray out into the world at the mouse position, and I'm going to move the spring joint position to that point, a distance out, hit distance out from the screen. And then this is one of the magic of the coroutines, is that I can wait for a certain amount of time. And in this case, I'm waiting for the next frame. So this yield return new wait for end of frame waits for the next frame. And so again, here I am in the world. I can pick things up, and those objects are attached to the mouse cursor by this spring, and I can drag things around and pull stuff and move things. Now, and then finally, when we're done, when we've released this this while loop, when we release the mouse button, this while loop then no longer triggers, and we clean up. We make sure we still have a connected body, and I reset that object's drag back to the old drag and the old angular drag that I had saved when I first connected it, and then I disconnect the spring joint connected body is set equal to null, which disconnects my spring joint from the object. Now, there's one other thing. In Unity standard assets, there's a copy of basically this script in the utility folder. And my one criticism of it is that the Unity version has all these tuning parameters that I had as exposed variables as consts, which means that they're named parameters whose values can't be changed. And what this means is that the strength of the spring, which is what it takes to pick things up, is set at 50 and can't be changed in the inspector. You'd have to go into the program and compile it. And so here's a heavy object. Everything else in here has mass 1, but here's a heavy object. And if I go to try and pick it up with a 50 strength spring, it doesn't move. It doesn't pick up. And so, and this is a problem with the utility script, because these are not exposed. You'd have to edit it and compile it and change the strength of the spring and recompile it. So I'm suggesting the following modifications. Add a public bool variable uniform force, and where in the routine where it sets the spring strength, there's 2 lines. Spring joint spring is K spring, and spring joint damper is K damper. If this uniform force toggle is true, execute this. Multiply the spring strength by the hit rigid body's mass. This makes the spring stronger for heavier masses, and with a stronger spring, we need stronger damping to quell the oscillations. So we also multiply the damper by the rigid body mass. If that toggle is not set, then we can just go ahead with the stored values. So now, in this version, the mod version, which is exactly the same, except that our camera now has the modified drag rigid body with the uniform force checked. Now I can go ahead and pick up the heavy object, just like I pick up any of the light objects. And the spring strength is adapted to the weight or the mass of the object that I'm picking up. So scaling the spring joint spring and damper by the mass makes it always strong enough to pick up an object regardless of its mass. I'm going to stop here. I'm going to stop the sharing, and I'm going to stop recording. I'll come back and finish the joints in a subsequent lecture. Bye.